We want to find a vector equation or vector valued function that represents the curve of intersection of the cylinder x squared plus y squared equals 9 and the surface z equals x times e raised to the power of y, where the vector valued function will be in this form here, where x of t, y of t, and z of t are the x, y, and z components of the vector valued function, which means we want to define x of t, y of t, and z of t so that it would satisfy both of these equations. If we take a look at this graphically, here we see the graph of the cylinder and the surface. We want to find the equation of the vector valued function that would trace out the curve of intersection. Looking at the equation of the cylinder and the surface, notice how the equation of the cylinder only contains 2 variables, while the equation of the surface contains 3 variables. Let's begin by focusing on the equation of the cylinder. Notice in 2 dimensions this would be a circle where the equation is in the form x squared plus y squared equals r squared, where r squared would be 9 and therefore r equals 3. And since we also know x equals r cosine theta and y equals r sine theta, we can define x as x equals 3 cosine t and y equals 3 sine t. And we can verify it would satisfy the equation using our trig identity here. So again, we're going to let x of t be equal to 3 cosine t and y of t equals 3 sine t. Now if we used sine for x of t and cosine for y of t, it would still work out. But let's go ahead and verify if this does satisfy the equation x squared plus y squared equals 9. Since x of t equals 3 cosine t, x squared would be 3 cosine t squared plus y squared, which should be 3 sine t squared, equals 9. So here we'd have 9 cosine squared t plus 9 sine squared t equals 9. If we factor out the 9 here, we have 9 times the quantity cosine squared t plus sine squared t equals 9. Well, we know cosine squared t plus sine squared t equals 1, so we have 9 times 1, which does equal 9, verifying x of t and y of t do satisfy the equation of the cylinder. So let's go ahead and write those down. We have x of t equals 3 cosine t and y of t equals 3 sine t. But remember, these also have to satisfy z equals x times e raised to the power of y. But because this equation is already solved for z, it's really a matter of performing it's just a matter of performing substitution, where z, or z of t, would be equal to x times e raised to the power of y, where x is 3 cosine t, so we'd have 3 cosine t times e raised to the power of y, so we'd have e raised to the power of 3 sine t. If we define z of t in this way, it would satisfy the equation of the surface. So again, z of t equals 3 cosine t times e raised to the power of 3 sine t. Let's verify this vector valued function would trace out the intersection of the cylinder and the surface. I've graphed the curve traced out by the vector valued function in red, and notice how it does trace the intersection of the cylinder and the surface. Let's go ahead and change the window so we can see more of the cylinder. Again, notice how the red curve traced out by the vector valued function is tracing out the intersection of the cylinder and the surface. I hope you found this helpful.